This ice cream and cake owe their existence to chemistry. Don't shake your head in disbelief because this is true. Many aldehydes and ketones are used not only in perfume industry but also as commercial food flavoring agents. For example, benzaldehyde is an aldehyde with a characteristic almond-like odor. So what's the role of these compounds in our daily life? Let's find out in today's episode. Hi, I am Devabrata Goswami. Let me welcome you to another fascinating episode of chemistry. I am sure you have eaten brightly colored food at some time. The bright orange jalebis come to mind. Well, if you go beyond the smell of the perfume and flavor of your favorite dish, you will find chemical compounds lurking there. One class of such compounds which are used as flavoring agents are known as aldehydes and ketones. In this episode, we will discuss general methods of preparation of aldehydes and ketones. Further down in the episode, I will discuss important chemical reactions of aldehydes and ketones. And finally, we will look at the important questions in the exam decoded section. So, what are aldehydes and ketones? Well, these are special organic compounds in which a carbon atom shares a double bond with an oxygen atom. The double bond between carbon and oxygen is characteristic of all aldehydes and ketones, and as you know, is known as the carbonyl group. So what is the difference between an aldehyde and a ketone? Well, an aldehyde contains at least one hydrogen attached to the carbon of a carbonyl group, whereas a ketone contains two alkyl groups attached to the carbon of the carbonyl group. Remember, at the beginning of the show, we talked about aldehydes and ketones being used in many food products to add fragrances and flavor. Why do you think that is so? Well, many aldehydes have pleasant odors. Benzaldehyde is one such aldehyde. At room temperature, it is a colorless liquid with a characteristic almond-like odor. It is the primary component of bitter almond oil extract. You will be surprised to know that aldehydes and ketones can be prepared from many different compounds. But initially, we will prepare them from acyl chlorides, which are also known as acid chlorides. And this method of preparation is called Rosenmund's reduction. In this method, acyl chloride is hydrogenated over a catalyst which is palladium supported on barium sulfate. A small amount of sulfur or quinoline is added to the catalytic mixture. This is done to prevent aldehydes from further reducing to alcohols. Now that we are done with preparing aldehydes, let's move on to ketones. How can they be prepared from acid chlorides or acyl chlorides? Let's find out. Ketones can be prepared by reacting acyl chlorides with dialkyl cadmium. Dialkyl cadmium is prepared by the reaction of cadmium chloride with Grignard's reagent. After preparing aldehydes and ketones from acyl chlorides, it's now time to see how nitriles are used in the making of these chemical compounds. Let's begin with aldehydes. Firstly, nitriles are reduced to corresponding imines by reacting nitriles with stannous chloride in the presence of hydrochloric acid. The imine on hydrolysis gives the corresponding aldehyde. This method is called Stephan reaction. Do you know that a chemical reagent called diisobutyl aluminum hydride is also used to prepare aldehydes from nitriles? This reagent is also known as dibal H. Let's see what happens in this reaction. Here, nitriles are getting reduced to imines by diisobutyl aluminum hydride. Imines then get hydrolyzed to aldehydes. Just like aldehydes, ketones can also be prepared from nitriles. Let's see how. To prepare ketones, a nitrile is first reacted with Grignard's reagent in the presence of ether. The product formed is hydrolyzed to give us ketone. That was all very serious. So, let's take a look at how aldehydes and ketones affect our lives. You must have seen avalanches in some movie. The sudden fall of snow from mountain peaks in large quantities is called an avalanche. They can be pretty dangerous and cause massive destruction. But chemistry has a solution to this problem. As usual, let's first figure out the reason these avalanches happen. As you know, snow falls in flakes, which are actually crystals. Rising water vapor gets attached to these snow crystals and freeze around its corners and form large sparkly crystals with cup-shaped facets. These large crystals are called depth holes. They make the glacier unstable. As more and more snow falls, the glaciers can break away and fall down the mountain as avalanches. But let's meet our hero, chemistry. Treatment with benzaldehyde and N-heptaldehyde may prevent avalanches caused by unstable depth hole layers. However, these chemicals are not in widespread use because they damage vegetation and contaminate water supplies. If learning about avalanches was a chilling experience, let's warm up now with a different exercise. Till now, we learned how aldehydes and ketones can be prepared. Let's take a short break, but don't go anywhere because I am coming back with some more interesting chemistry for you. But before going on a break, I have a question for you. I'm sure you have seen camphor. We use it for medicinal purposes and also in religious ceremonies. Do you know which functional group is present in this compound? You can find the answer on www.topperlearning.com. I'll be right back with all the answers and some more chemistry.